OpenAI should be scared right now. There's a new player in the open source model space that isn't just close to ChatGPT performance, it's beating it in a lot of ways, and it is comically cheaper too. And I mean comically cheaper. We're talking a reduction from $15 per million tokens to 55 cents and $60 per million output tokens to $2.19, 96% cheaper. And this is on GitHub because it's an open model that you can download and do whatever you want with. There are catches, but there are incredible things going on here too. As the first, as far as I know, ready for production open source reasoning model, there are so many interesting nuances to go into here, and I'm really excited to do all of that with you. From comparing performance to other models to showing just how good it is, as well as diagramming out all the things that are good, bad, and ugly about it, how it works, why you might want to be careful, and a whole lot more. Stick around. Before we can do that, a quick word from today's sponsor. If you're watching this video, you're probably a pretty good engineer. What about the engineers around you though? Do you want to hire the best? Do you want to have a team full of people that are as talented as they could be? We all do, but it's getting harder and harder, especially as we get flooded with these terrible, useless AI resumes. That's why I partner with today's sponsor, G2I. These guys get it. They will make it way easier for you to hire the best engineers, and you'll know what you're getting as you go in. When I say these guys get it, I mean it. They run React Miami, which is my favorite React event. Sorry, ReactConf. Seriously, you should check out React Miami if you can go next year. It's super fun. They also help giant companies like Webflow and Meta with their hiring. So they're not just helping random small startups, but they will help yours if you're interested. What really makes these guys different is the pool of talent they have ready and available to go. We're talking 8,000 engineers that can start literally under a week. You're not just reading a resume and hitting a checkbox. They have full remote video interviews that you don't even have to show up for, where they do the video interview and show you the results. You can even pitch your own questions that will be asked and get a video response back. So you actually get to know the human who you're going to be working with. And they can help hire pretty much anywhere, from US and Canada, Latin America, and even Europe. And it's not just full-time engineers either. You can have part-time contracts through this as well. When you start working with G2I, they'll form a Slack channel with you with almost immediate updates. These guys are on the ball. They're one of my most responsive sponsors. I know they'll be even more responsive with you guys. If you're trying to hire great engineers and get them shipping fast, it's hard to beat G2I. Their goal is 7 days from interview to the first pull request being filed, and I've seen them hit this. I think they will for you too. Check them out today at soydev.link/G2I. So first, we should probably better understand what a reasoning model is. I'm going to give the example on ChatGPT quick. Got to sign in because I'm still switching over browsers. So ChatGPT has a bunch of different models. O1 is the one that we care about here. It is an advanced reasoning model. What that means is if you ask it to do something, it's going to think about the thing before it does it. So I'll just ask it, how are oranges grown? And you'll see it is thinking, thought about orange cultivation for a second. So it didn't think about it for long. It just immediately went into an answer. But if you give it a harder question, like solve advent of code 2021, day 12 in Rust, you'll see it's thinking. And it will give you a little bit of vague information on what it's thinking. Navigating the cave system, because I'm assuming there's a cave system in this problem. Parsing and counting. So the way that these models work effectively is instead of just taking your prompt and trying to autocomplete the rest, which is effectively how most AI models work. They're just a fancy version of autocomplete using all of the words before to guess what word is most likely to be next, which works great because after a question mark, the thing after is most likely to be an answer. Here, instead, it adds a question that is, how would you solve this? So come up with a process, and then it goes through each of those steps and verifies them. It doesn't show you much of what it's doing. It gives you these tiny little blurbs that it's thinking. And since the model isn't open source or self-hostable, you have no access to it. We don't really get to see beyond this rough idea of it thinking what is going on. And it spits out an answer, all works fine. Oh, it's not even done. I consistently forget how slow ChatGPT is. Shout out T3 Chat, we'll get there in a bit. This is how reasoning models work though. One of my favorite things about the new Deepseek model is that it's open source. And because it's open source, they're a lot more willing to just show you what it's thinking. You can see a bit more detail here of how it thought about these things, like what the steps it came up with were, but it's not that much info. In contrast, let's run a quick test using Deepseek R1 on T3 Chat, which is now available for all users on the $8 a month tier. Deepseek R1. And now you see I have this folded down reasoning. We'll make the UI better. Chances are by the time you're using it, we've already fixed this. But in here, you can see the full plain text of all of the reasoning that it is doing. I need to solve Advent of Code 2021, day 12 with Rust. Let me read the problem statement again to make sure. Right. So part 1 probably requires counting all such paths. Example has given a few test cases. Let me think about the approach. and it gives you all of the info of how it is thinking about this as it goes. This has a negative in that it's slower to get you the answer. It also has a negative that when you're doing this, it costs a good bit more in the server side because you're generating way more tokens than you would be just spitting out a traditional output. But as a result, you get much more accurate and consistent answers. But as you see, we're spending a lot of time thinking, figuring out what we actually want to do here. But it gives you so much context on how it is thinking. And this is awesome because it lets us better see where our models are stumbling, what problems it's not getting, make better prompts in order to make it more likely to generate the right answer at the end. It's real cool. It's so insane seeing this deep into how the model is thinking. I'm genuinely really impressed. That said, if you give it a hard enough problem, it will just go. Like it's still going here. On one hand, it's given us significantly more context than ChatGPT did. Here we see all it gave us was these 4 paragraphs. And what we're getting from R1 is a hell of a lot more. But now I'm scared we're going to hit a timeout before it actually finishes generating because it's so much. Jesus. I might have to bump our timeout window again. It's a hard problem. Oh, cool. I got an answer. I should have timed how long that actually took. But we did ultimately end up getting an answer from R1. I'll see if it works. But first, I want to see if the ChatGPT one works. So let's see. Part 2 is 146553, 53333. Look at that. Solid. And if we see if the one here works, copy, paste. Oh no, did it not finish the code output? Did it die right before finishing it? RIP. Took 291 seconds. Huh. Interesting. Here's what we'll do. We'll tell V3, finish the code from before. Let's see if the finished version here will work. Do we have a main? Yes, we do. Cool. So finishing up with Deepseek V3 worked. Kind of funny to do it that way. But I am going to test one last thing, which is giving the same prompt for a relatively hard advent of code problem to a dumber model. Gave it to 4.0 mini, copy. It could not. Joyous. And obviously, everyone's favorite, we'll test it with Claude. I'm so happy to have an AI chat that doesn't suck. Someone who's been playing with these things a lot more. I'm so annoyed with everyone else's UIs. And look at that. They got it wrong as well. Even a advanced, smart, super powerful model like Claude can't successfully solve this problem. This is why these reasoning models are magic. It's like, oh, sure, generate a solution. It's the only model that is able to successfully generate a solution to a problem of this difficulty, which is really cool. This is now the difference between models that can help with small things but not solve hard problems, and now they can solve much harder problems. It's super impressive. As I mentioned before, it's open source. That doesn't mean all of everything they use to train it is there for you to use, but it does mean the model itself can be downloaded and run. I've seen people running this on their phones already, which is nuts. It's one of the lighter models, but it's still really powerful. By the way, I'm such an AI guy now that I'm even posting on LinkedIn about it. I'm so sorry for my sins. With O1, 1 million input tokens costs $15. With R1, it costs 55 cents. 1 million output tokens with O1 is $60. And with R1, it's $2.19. That's insane. That is unbelievable difference. This is cheaper than Claude is. Sonnet is $3 for a million in and $15 for a million out. Deepseek is 55 cents for a million in and $2.19 for a million out. Are you kidding? Do you understand how monumental this is? This fundamentally changes when using these really smart models makes sense to do on like a deep level. Interesting to see to forward Deepseek's R1's thinking tokens into Sonnet. Ooh, that's an actually really interesting suggestion. What if we took how Deepseek thought and handed that as additional context over to Claude? Let's give that a go. I'm actually very curious. So we have this reasoning dump here. Let's copy the whole thing. I hate myself. We'll add a feature for this in the future. I am in so much pain right now. I've never been so ashamed of my own service. Solve Advent of Code 2021, day 12 in Rust. Here's some thoughts on how to do it. Paste a lot of text. Hope that is not outside of the context window. Now let's see if using the context that was generated by R1, if we can get a decent answer. Cool. This looks to be a really interesting test. Holy shit, that worked. Clever chat. So the term for all of that thought, all of the dump that was there, all the reasoning is chain of thought. It's the thought that the model went through before generating a result. And what's interesting with this model is they're doing a lot of different things with that. If you check out their GitHub, they're very transparent about how they're doing this and what they're thinking about. I was expecting them to build this almost entirely around the DeepSeek V3 model because it's a good model. But what surprised me here is that they actually created 6 dense models distilled from Deepseek R1 based on Llama and Qwen. Llama's the model from Meta, as we all hopefully know by now, but Qwen is the model from Alibaba, of all places. And it's actually pretty good. But when you take advantage of the reasoning layer in front to hand it more context and ask itself more questions, the result is kind of insane. Like to have a Codeforces score that is right at the same line as OpenAI's best in class for literally 96% cheaper, insane. How could they possibly ever have done this? I want to do a DeepSeek video about version 3 when it dropped because it was so interesting, but it wasn't quite enough to cover. It's actually one of the biggest inspirations for me to make the whole of T3 Chat. Originally, T3 Chat only supported DeepSeek, but sadly, DeepSeek's V3 model started to get slower. Tangent we'll get to. So I made the last minute call to switch us to 4.0 Mini. That said, I've been really impressed with what DeepSeek is doing because they're doing it very different. The biggest difference for how DeepSeek works is that they're training on generated data. This is a big change. There's a quote from Ilya that's been haunting me for a while now. Ilya said in a presentation recently that data is the fossil fuel powering the AI world. And he's so right that it hurts my brain. What that statement means is, effectively, all LLMs are really, really advanced autocomplete. So if you're typing on your iPhone, hey man, whatcha? And then wait, your iPhone will start making suggestions for what word is next based on all of the other things you've typed in the model it has created on your phone based on its knowledge and history of what word is most likely to come after whatcha with this context. And you know the meme where you just hammer the recommended next word button to see what your phone thinks about you. It's effectively that. And it turns out if you ask a question like, how are oranges grown? If you have enough context from the entirety of the internet, the thing that is most likely to be immediately following a question is an answer. And it's probably pretty likely that the next word is oranges and then more things. But it is almost entirely based on the probability scanning this insane amount of data of what is most likely to be next. This is a gross oversimplification. The point being, this will give you a rough mental model of how these things work. They are trying to find the most likely next word based on the previous words. In order for this to work, you need to have an insane amount of data. So OpenAI and Anthropic and all the other companies that were early enough scraped all of the data they could find on the web. So if you have all of this data on the web, we'll say conservatively, half is accessible. The other half is inaccessible. Either it's paid-walled, it's behind off walls, it's dead links, it's whatever. But conservatively, you could maybe argue that half-ish of the web was accessible for them to fetch data from and train. There were places like Reddit and Twitter that were super generous with their APIs where you could just hit the Twitter fire hose and get an event on every single tweet that was public. That was crazy. And on Reddit, you could just kind of hit their APIs however you wanted and they didn't care. These companies changed that because they saw all of the value being generated by these platforms. If OpenAI theoretically cost both Twitter and Reddit a couple $100,000 in API calls, it's probably a little less, but it's probably not that far off. Reddit gets nothing for that. Twitter gets nothing for that. And OpenAI is now capable of replacing both. Same with Stack Overflow. And there's been a lot of numbers being posted of how Stack Overflow is declining. And if you look at the dates, pretty much since ChatGPT came out, the usage of Stack Overflow has been plummeting. Even during COVID, where you'd think there are more people programming at home, they don't have coworkers to ask, numbers plummeted because so many people are just moving to AI tools. And those AI tools are largely trained on Stack Overflow and things like it. So it's kind of cannibalizing the market around it. Kind of insane to see how steep this decline has been since these tools got really popular. But you can also, hopefully from this, understand why companies like Reddit, Stack Overflow, and Twitter would no longer want to give this data away for free. So the crazy thing that's happened is maybe this is what the split looked like when Anthropic and ChatGPT collected their data and started training. I would bet it's looking more like this now. less and less data is accessible. If you wanted to scrape everything you could from the web in order to make your own model, you would have a better time doing that in 2020 than you would right now. There is less accessible data, even though there is more data. But all this data kind of does live somewhere. All of this data, all of the stuff that was accessible on the web has effectively been, in a way, condensed. If we have this giant pool of accessible data, let's say it's this big, the data OpenAI used. Theoretically, all of that data is this big, just for reference. You can still kind of access it, just not in the traditional sense. You can't go scrape it, but it's in here. It's embedded in the OpenAI models. So what if you get it out by asking? What if instead this data was used to train something smaller, but it contained most of what existed? This smaller thing is the OpenAI model trained on the data. This might be a lot smaller, but it should realistically contain the majority of the value of the data that it was trained on. Where things get much more interesting is when you realize that if you can't get this, one of your best bets is actually going to be to go this way instead. If you can't access the data that OpenAI used, what if you use the thing they trained that is a distilled set of that to generate more data? Maybe use it to generate way more data. This data, this sources of truth, this everything that powered ChatGPT and OpenAI originally can be used to generate a ton more data. So this is what they did with Deepseek. Deepseek was trained on generated data. So using the existing models, they can generate all of the data they could theoretically need. And your thought might be, oh, that sounds terrible. Why would you want to use synthetic data for something like this? There's no way that's as good as human data. Well, I have some good, or depending on who you are, potentially bad news. Google disagrees. Google has a DeepMind arm that is doing research similar to what OpenAI does to figure out what makes sense and what does and doesn't work when trying to train these models. And they did a study in April of last year on best practices and lessons on synthetic data for language models. And most people's expectation here was it might work, but probably not that well. If we scroll down here to the conclusion, synthetic data has emerged as a promising solution to address the challenges of data scarcity, privacy concerns, and the high cost in AI development. By generating realistic and diverse data sets, synthetic data enables the training and evaluation of AI models at scale across various domains. As we approach human level or even superhuman level intelligence, obtaining synthetic data becomes even more crucial, given that models need better than average human quality data to progress. However, ensuring the factuality, fidelity, and lack of bias in synthetic data remains a critical challenge. These models don't know what they are. They just know the data they have. It's very funny to ask them what they think they are because 4omini thinks it's GPT-3 based. Deepseek v3 used to confidently think it was GPT-4 because they trained it on so much data from GPT-4. And if inside of your generated data, if one of the little tiny facts in here, because it's literally just infinite numbers of questions and answers, if one of them is, what model are you? And the answer they have most common for that is GPT-4 or whatever. If this exists in here hundreds of times, it doesn't matter what else you put in for the most part. It's going to resource and make decisions based on what the most common thing it has in here is. And if they trained it on a shitload of questions and generated a shitload of answers, it's going to struggle. Yeah. But those are small costs to what is otherwise a pretty big win. One way to think about this that I have felt makes a lot of sense, that has helped me with my own understanding, is to think of this kind of like image compression, where if you were to literally take a picture, like you took an image, and let's be conservative. Let's say it is 3x3. It's 9 pixels. Obviously, pictures are usually a lot more than 9 pixels, unless they're streaming on Twitch. But you get the idea. We have this picture. It has 7 blue pixels and 2 orange pixels. This in and of itself is actually a decent bit of data to store, to have the full hex code, the 6-digit hex number for each of these spots times the number of pixels. That's a lot of data. And when you have enough pixels, it's rough. So what you often end up doing is finding ways to group it or reduce it. A common one is you'll take a section, like a group of 4 like this, and you'll average it. So you'll say this group of 4 averages to blue, just make it blue. This group of 4 averages to a perfect split between blue and orange, so make it a split. And different ones will have different values. You can see how this works with certain colors very well. This is going to be a weird example, but it's one that comes to mind immediately because I just saw this. And going through multiple layers of YouTube compression is going to make it even funnier, so stick with me, it's worth it. I was watching a Young Lean music video on my OLED TV a few days ago and was horrified, like disgusted at the quality of the black and gray compression. Let me find a nice muddy moment. There's a lot of them in this. Oh, yeah. No, the quality of the stream didn't go down. No, the quality of this video isn't low. You are really watching a 4K video, but the compression of the grays is inexcusable. There's like 3 colors of gray around him in a lot of these scenes. Like here, it's so blotchy. It's unbelievable. Look at that. There is 4 colors in this gradient. Like, holy hell. And this isn't even just a normal like 1080p HD upload. This is in the enhanced bitrate. It still compresses down to like 4 colors. And you end up with these awful blotches that just drive you insane. This even hurts our videos a lot because I have my black background. And chances are, if you look at this, when I'm looking at it in my monitor, it looks great. But when you see the compression for it, it's going to look blotchy as hell. And there's nothing we can do about that because the compression is aggressive and it sees colors that are similar. And instead of putting each line for those individual pixels, instead of specifying this pixel is this gray, this one right next to it's a slightly different gray, gradients are really hard to compress because there's a lot of different colors in the range. This means anything that changes quickly or has a range of numbers in a small area, especially things like confetti, suck to compress. And seeing this Young Lean video at the very least made me feel better about the quality of the grays in my videos because I'm not the only one. And even on high bitrate options on YouTube, the colors get screwed. So why are we this deep talking about compression of colors in images when we're talking about AI? This is the model I've been using mentally to better understand why the synthetic data thing is good. First and foremost, you could argue that the way OpenAI trained, having all of this data and then squeezing it into a large language model, it's effectively a method of compression. When you take a large video that is the immediate literal frame data, like when I'm filming on my fancy camera with all iframes, each frame has the option to generate with every single pixel's exact value. Funny enough, that makes video editing easier because your editor doesn't do as much work, but it makes moving the files impossible because it would be like a terabyte instead of 15 megabytes. Transcoding that large video file with every single pixel encoded to a compressed format is a thing that takes actual compute, usually GPU compute. Traditionally, the chips on your device that do that video encode would be on the graphics encoder, on your graphics card. One of the reasons I'm on NVIDIA for all my encoding for my streams is because they have a chip called the NVENC encoder that does a really good job of taking a frame with exact pixels and then turning that into a somewhat compressed image. That's the same reason that GPUs are used to train these models. They are trying to take this complex, massive data set and compress it to something way smaller that is effectively a map between the actual data within it so that a smaller, simpler computer can decode it. If you have a video that has all of this data, and it's a ton of data, and you re-encode it to something way simpler, we'll say instead you have a smaller grid that's like a grid of 4 things. So I'll delete 2 of the lines. This would have been a lot easier if I did a grid of 4x4 instead of 3x3. So just stick with me, guys. You will understand the concept even if the diagrams suck. Let's say that your compression turns it to this, and then turns this into a really simple string of BBBO. Now you have this much, much smaller output that doesn't have 6 digits of hex per pixel. Instead, it has 4 digits total. Now you need something to transform this back. And it turns out taking this compressed thing and making it back into something close to the original video is a lot less work than taking the original video and compressing it into that format. So for the task of going from a raw video where every pixel is encoded to something much smaller that most devices can play, that uses way less storage and bandwidth, that takes a decent bit of encode power. Going the other way, way simpler. Taking the nearly infinite amount of data that OpenAI is training on and compressing it into something digestible takes an unfathomable level of scale. It takes an insane amount of compute, and it's the reason that NVIDIA makes the money they make now. Once you've done that, though, actually running the model is nowhere near as bad. It still is challenging. It's not like you could run O1 on a phone, but you could run smaller versions of R1 on a phone, which is pretty cool. But if you use this result now, this thing that is much simpler, to generate even more data And then you use this to train something even smaller than what OpenAI built. If you have enough data to practice and optimize your compression with, it's not necessarily that more data means less compression, because if you can make this data fit a shape and a pattern, it's a lot easier to compress. SVGs are way higher fidelity than a PNG for certain things because it's telling you where to draw the line, not which pixels are where. And if you can use this model, this compressed thing, to generate data that compresses more easily, you end up making something much more efficient, like Deepseek V3. And this model is insane. Even with the price hike that they're about to do, even once they change the price, it's going to be 27 cents per million input tokens and $1.10 per million out. I would say that DeepSeek's V3 model is most comparable to what's being offered by Anthropic's 3.5 Sonnet. We're talking about a change of $3 per million tokens to 27 cents and $15 per million output to $1.10. That's insane. And I honestly think the quality of this model is comparable to what you get out of Claude and Anthropic. Insane. And they got there with a ton of synthetic data. I think this represents a significant change in how models will be created. It is now effectively possible to put the open back in OpenAI by using their model to generate data that you then expose via an open source model that anyone can use for free. But I do want to dive a tiny bit into conspiratorial land. I don't know if I'll even put this in the video. It's probably going to get me in a bit of trouble. What we're not talking about much is this arrow. Because when you create this data, you have the ability to massage a lot of things. I've learned a lot as I've played with system prompts. And if you are generating 100% of the data that is being used, you can do a heavy amount of filtering of this data by injecting a system prompt between OpenAI and your data pool. Let's say, theoretically, there was a cartoon character that your government didn't like. I don't know. We'll just say Piglet. Let's say for some reason your government didn't like Piglet. You might be able to say, never, ever, ever, under any circumstance, mention the cartoon character Piglet. And now, despite having more data than OpenAI trained on, you're now able to influence this in a way that you can't simply system prompt around. Now, if I was to try and make something like, even if I built my own system prompt on top of V3, and I said, list all of the Disney characters, if in its data, it's never seen Piglet because it was filtered out via a system prompt ahead of time, this model now has a bias intentionally embedded within it that allows you to effectively remove things from the data sources. And if this model is so much better than anything else that you can get, and it's open source, you're now able to effectively bias the entire community of people building around these tools. Because at this point in time, it is effectively irresponsible to not be using DeepSeek models if they are an option available to you for the things that you're doing, because they are so much cheaper, they are often faster, and as long as you're not asking about a theoretical cartoon character that they don't like or other things they might have biased in, if you're just asking it about code, it does a phenomenal job. Obviously, OpenAI could theoretically have put their own filters on the data here. In fact, they certainly had to make the data high enough quality to train against. But it's a lot easier to inject a system prompt before generating a bunch of data. And the crazy thing here is you can inject additional biases. You can tell it to favor something. And while you could filter data that doesn't favor the thing you want, now you can generate data that does. If you theoretically hated React and really liked Vue, and you didn't want this model to recommend React by default, you could tell it to not ever recommend React code and always recommend Vue. And now when somebody says, how should I get started to code? This will have a different result in the output. This is all fascinating. This is a very interesting chain of events that results in a model that is way cheaper, way more efficient, way better compressed. It's like the AV1 of AI. But it also means that the owner of the training for this model can do things that we might not like, and most importantly, that we cannot see, because they're not even showing us this synthetic data pool. All they are doing is telling us that they used one, and then they are giving us this output. It's a fascinating thing to be considerate of, the biases that go into both the data that they find and filter, as well as the data that they generate and train on, that you should be considerate of as you use, consume, and think about these models. So do your best to at least think about the biases that might have been present with the creators who made these things, because there's a real concern here that a lot of the investment going on into DeepSeek, and the reason that they're making it so cheap and open source, is because they want it to become the default model. And the reason that's beneficial is any biases they've trained into it are now going to be the default for every single thing that recommends and uses this model. Interesting thing. That means I hope we get better open source models trained all around the world on different data and in different ways. Just a thing worth considering. I've been spending a lot of time on artificial analysis. This is one of the few sites that does a good job of actually giving you real benchmarks for a ton of different things. One of the real interesting things I learned from spending a lot of time in here is about DeepSeek. Obviously, as you look here at the performance, and this is filtered to only be like really good models, it's consistently performing near the top. It's like right neck and neck with Claude for most things. There are certain places where it suffers, isn't quite as good. And obviously, the reasoning models like O1 are going to be slightly stronger overall. But the thing that I learned about DeepSeek that's been really painful and sad is in the speed that it does output tokens. I care a lot about speed more than most AI bros because I want a good user experience. And if we look here at output speed, you'll see something interesting. O1 Mini's 217 tokens per second. GPT-4o Mini is 77 tokens per second, which is sus because we're a lot faster, which we'll get to. But also DeepSeek V3 is at 17. When I started using DeepSeek, it was over 90. And this is the only time I've ever seen this. But if you look at the output speed over time, when DeepSeek V3 dropped and you could use it through their API, you could consistently get 90 tokens per second, and it has slowly plummeted. So through their API, it gets about 40. And since it's open source, there are other providers like Together, Firework, Hyperbolic, but none of them are even breaking 30 tokens per second with it. That's insane. A lot of them are actually quite low, like getting 10 TPS, which is not a good experience at all. It's just, it feels terrible. But it can go fast. I think they're just dealing with insane amounts of traffic, and their self-hosted DeepSeek API has gotten slow enough that it's no longer the default in T3 chat. The other fun thing, and I almost don't know if I want to show this to you guys because it's one of the secret sauce pieces that makes T3 chat feel so good. We go to 4o Mini. OpenAI's models can only be hosted one place, which is Azure, because Microsoft has a partnership with OpenAI. So if you're not using OpenAI's API, the only other place you can get their models is through Azure. But since, unlike OpenAI, Azure is actually relatively competent at hosting, you end up with meaningfully faster output speeds on Azure, sometimes comically so. It looks like Azure had a huge drop. Maybe their thing for testing it broke or overflowed. But from our experience, we've been consistently in the 180 to 200 range, which is double or more the speed you get from OpenAI. So yeah, if you want to use OpenAI's models and have them be a little more reliable and a lot faster, good luck with Azure, because it's not fun, but it works. So yeah. But in the end, I'm blown away. The fact that we can get this level of reasoning that is this open and transparent for what it is doing and how it is doing it, that is consumable and reasonably fairly priced, so much so that we can offer it on our $8 a month tier for T3 chat. That's so cool. You can now get what is benchmarks-wise the best model ever built, and you can do it all for $8 a month through here. That's incredible. The fact that we can even offer a price like that without dying, while meanwhile OpenAI is losing money on their $200 a month subscription, is just insane. And what this means for the future and for crazy things like a reasoning model that has different sub-models it will use for each step. The fact that you can generate these things on your phone now, the fact that this is all a race to the bottom in price and a race to the top in quality. It's going to be a crazy year for AI stuff. And that video I did a while back about how AI isn't meaningfully improving is the dumbest thing I've said in a long time. I'm genuinely excited for the future. If you are too, go give T3 Chat a shot. If you want to try these things, we will be going out of our way to continue adding all of the most state-of-the-art solutions for you to play with, experiment with, and see the best of the best. This has been a fun dive for me, and I hope it was for you as well. Let me know what you guys think. Until next time, peace, nerds.